Hi everyone, my name is Brandon.
I'm Joseph.
And I'm Richard.
And together we built Offramp. Currently React is the most popular library for building large-scale web applications. But the problem with React applications, we don't always derive our state from within our application storage, forcing us to use lifecycle methods. So as we can see with our Instagram example, as we navigate our views, our router will render our components and then our state will be updated after lifecycle method is completed. The problem with this is our router is mounting the state without having access to all the application state. This prevents our UI from being a function of our application state.
So that's why we built Offramp. Offramp is a routing library for React that handles decoupling of state and UI. This effectively eliminates the need to use component lifecycle methods in order to fetch data. So in the previous example, with our library, we remove the initial rendering of the component and wait until all the data is available before rendering it.
So with Offramp, we wanted to provide a simple and familiar API. So to get started with MobX, you simply import a router store, a router, and a route component from our library, and then pass our router store into your top-level stores object. And it's just as simple with Redux, except we're going to be importing our router reducer and combining it with your application reducers. Then simply import the provider API, pass it in our application store, and then define your routes, and our library will handle building the nested UI for us.
Here's how it works. Now, with our router store being passed into a provider, our router will now have access to the URL state. In order for our router to find the correct component to render, our router does a recursive call that traverses the DOM tree in order to find a subtree depending on the current URL state. To do this, we use a parsing algorithm to find a match between the current URL and the route's path. Once the match is found, the router store is updated with the current URL state, making it accessible to all of the children components of the router.
In most React applications, data fetching typically occurs in component lifecycle methods. By supporting asynchronous hooks, we allow developers to fetch data directly inside of our router and allow them to use stateless functional components. And so in this example, here all we have to do is declare a hooks object and define the hooks we want to use for any given route. Here we're using a before entered hook in order to fetch data from our API and return a promise. Then pass this hooks object into the route component, and our route component will handle the data for you.
So let's go ahead and see all this put together. So to navigate between our views, Joseph will use a custom built-in link component from our library. And as we can see, as the view changes, the current URL state is represented inside of our application store, making it easily accessible from within our app. Now, to show what happens with our async hook, we first want to show what happens when we use a typical lifecycle method. So as we click on projects, we'll see that our router will render the current component prior to having access to all of its state. Now, if we go to the developers tab, our router will first make sure to have all the state before rendering the component.
The benefit to using our router is that we're able to it is easier to reason about the flow of our application state because all of our state is in one single container. This allows us to debug our application easier. More importantly, we are able to eliminate the need for lifecycle methods when using data fetches. And so that will allow you to create components that are stateless, functional, reusable, and predictable.
We really enjoyed building Offramp, and we're really excited to share with the open source community. You can check us out on GitHub, NPM, or on our website, offrampjs.com. We want to thank all of you guys for coming out today.